Welcome to the Deep Dive. Today we're tackling a really ambitious project, one that didn't just aim for a new blockchain, but set out to, well, basically rebuild the entire public internet.
Yeah, we're diving into the Internet Computer Protocol ICP from the DFINITY Foundation.
And it's got this huge vision, but also, let's be honest, a pretty turbulent market history. Makes it a fascinating, if complicated, subject for us to unpack.
Absolutely. It's perfect for a deep dive because of that ambition. Replacing the whole centralized IT stack. That's the goal. But that vision definitely ran into some serious headwinds.
Big time. An explosive launch, then one of the most dramatic price collapses we've seen. It created this whole narrative of controversy that, frankly, often overshadows the tech itself.
Which is exactly why we're here. We've gathered the sources, technical papers, roadmaps, market commentary, some of it pretty critical, actually.
Yeah, some really critical stuff in there. So our mission is to synthesize all that. We need to get into the architecture, which is quite different, understand their unique economic model.
And balance those huge tech claims against the tough market reality and the adoption challenges it's faced.
Okay, let's start with that grand vision. Why did they think the internet needed a complete rewrite in the first place?
Well, the problem DFINITY points to is centralization. Simple as that, really.
Right. Big tech monopolies, Google, AWS, Meta, they host almost everything. Content, services.
Exactly. And that means all your data, all the functionality, it's locked inside these corporate ecosystems, which leads to massive platform risk, right?
Yeah, a company can just change the rules, pull the rug out from under developers. It stifles innovation because they control the fundamental infrastructure.
An ICP solution isn't just another app layer. This is key. They're aiming to build a whole new stack, a decentralized, scalable cloud infrastructure for storage, processing, governance, the works.
So the source material calls it an open internet, like TCP/IP, but for software itself.
Pretty much. The idea is software and services running directly on the public internet via the Internet Computer Protocol, not locked away in Amazon's or Google's servers.
Now, when people in crypto hear world computer, they immediately think Ethereum.
Right.
But this sounds much bigger. They're talking about replacing hosting, DNS, firewalls, databases, everything. Isn't that a massive overreach?
It sounds like it, but I think from their perspective, it's necessary. If you genuinely want to compete with AWS and Google Cloud, not just other blockchains like Solana or Avalanche.
You have to go that big.
You have to aim for the whole stack. And that requires a system designed for, theoretically, unlimited data and really high speeds. Which brings us nicely to the architecture.
Okay, let's look under the hood then. It starts with hardware, right? Dedicated node machines in data centers.
Yep. High-end servers acting as validators spread out globally. But the key is how they're organized.
Into these things called subnets.
Exactly. Think of a subnet as its own high-speed blockchain, basically. A collection of nodes working together. They need them for a couple of big reasons.
Okay, like what?
One is parallel processing lets the network scale out by running things simultaneously across different subnets. The other is fault isolation. If one subnet has an issue, it doesn't take down the whole internet computer.
Okay, so that's the infrastructure layer. And the actual software, the apps, they live inside canisters.
Correct. Canisters are ICP's version of smart contracts, but, well, they're way more powerful.
How so?
They hold both the application code and the data, the state. They function almost like a self-contained web service or, a component of an operating system that's just always running. They can serve web pages directly to users, handle data, process payments.
And the crucial part is that entire canister code and state gets replicated across all the nodes in its subnet.
Yes, for security and redundancy. Every node in the subnet runs a copy.
Okay, but replication usually slows things down, right?
Yeah.
If every node is doing the same work, how do they get the speed they claim? This must be where that chain key technology CKT comes in.
Bingo. CKT is kind of the secret sauce here. It's a suite of advanced cryptographic techniques.
Doing what exactly?
Its main job is coordinating all those nodes and subnets securely. And it enables something quite remarkable. The entire Internet Computer Network effectively has a single public key.
Single key for the whole thing. Why is that such a big deal for speed?
Because it means any device out there, your phone, your laptop, whatever, can verify the authenticity of anything coming from the Internet computer in milliseconds. It doesn't need to check endless block signatures or complex proofs.
Just checks against that one public key.
Essentially, yes. It makes verification incredibly fast, regardless of how big the network gets. Combine that with the sharded subnet architecture, and that's how they make those bold performance claims.
And the numbers we have are pretty striking, especially when you compare them.
Oh, yeah. The source data puts ICP's real-time TPS at over 1,081 transactions per second. Compare that to Ethereum's, 16 or 17?
Huge difference. And the block time.
Even more dramatic, maybe? ICP is hitting around 0.48 seconds per block. Ethereum's is 12 seconds. So, yeah, 96% faster block finality. The claim is clear. They believe they've built something that can actually match Web 2 speeds.
That kind of performance of that different architecture, it must need a totally different economic model too. Let's switch gears to the tokenomics. It's a dual token system.
It is. You've got ICP, which is the main governance token. It has inflation, but the rate decreases over time.
Okay, and the second one?
That's cycles. Cycles are the computation fuel, and they're designed to be stable.
Right, and this is where we get the reverse gas model. This is probably one of the most unique aspects. How does it actually reverse the typical blockchain incentive?
So normally, like on Ethereum, the user pays the gas fee for every single action they take. Click a button, pay gas.
Which is a huge barrier for normal people.
A massive barrier.
Yeah.
With ICP, it's flipped. Cycles are created by burning the ICP token, and 1 trillion cycles are pegged to the value of one SDR. That's the IMF's special drawing, right? A basket of currencies. So it's stable-ish.
Okay, so ICP is burned to make cycles. Who uses the cycles?
The developers, they buy cycles and use them to pre-charge their canisters. It's like topping up a prepaid phone card, but for your application's computation and storage needs.
Ah, so the developer pays the compute costs up front? Like paying an AWS bill?
Exactly like that. They pay their rent for their application. And the cost is pretty efficient, apparently around $5 per gigabyte per year for memory.
And the massive consequence of this is?
The end user pays nothing. They interact with the app, use its features. No need to own ICP tokens, no need to worry about gas fees. It just works.
That is genuinely a game changer for usability if it works at scale.
Huge. It potentially removes that core friction point of Web3 for mainstream users.
Okay, so developers pay. How is this whole massive decentralized IT stack governed? That's the network nervous system, or NNS. Yes, the NNS, it's their on-chain DAO structure. It's quite involved.
How does it work?
Basically, you stake your ICP tokens to create what they call neurons. These neurons give you voting power.
Voting on what? Everything, pretty much. Proposals to upgrade the protocol, manage the subnets, adjust economic parameters like inflation or the cost of cycles, the whole shebang.
And there are rewards for participating.
Oh, yeah. Node operators who run the hardware and neuron holders who vote get rewarded with newly minted ICP. That's the inflation mechanism at work, rewarding participation and security.
But there's a catch to getting more power and rewards, isn't there?
Yeah.
Something about locking up your tokens.
Yes, a significant one. To vote and maximize rewards, you have to set a dissolve delay on your neuron. It's basically a lockup period.
How long?
It has to be at least 6 months, and it can go up to a maximum of 8 years.
8 years. Wow.
Yeah. The longer you lock up, the more voting power your neuron has, and the higher your rewards. It's designed to heavily incentivize long-term commitment and align participants with the network's stability and success over time.
Okay, so we've got this picture of, potentially revolutionary tech, a unique economic model, long-term focused governance. But we can't ignore the market side. The financial story is, well, it's rough.
It's unavoidable, yeah. The numbers are stark. Launched May 2021, right near the bull market peak. Price hit around $750.
And now, mid-2025.
Trading around $5 or $6. That's what, a 98% drop from the all-time high? Maybe even more. Just brutal compression.
And that massive drop fueled so much controversy. Our sources really highlight the criticism around the initial token distribution. What was the main accusation?
It really centered on the allocation. A very large chunk, something like 68% of the initial supply went to early backers, seed investors, strategic partners, the DFINITY team, and foundation itself.
Okay.
And the critics point out that the unlock schedule for many of these early tokens, bought way back in 2017 or 2018 for pennies, coincided pretty closely with the public launch when the price was sky high.
So the argument was?
The accusation, plastered all over forums at the time, was that retail buyers who came in at the public launch basically served as exit liquidity for these early insiders who were sitting on 100x, maybe even 1,000x gains.
Concentration risk meeting peak market euphoria. A recipe for disaster, potentially.
Yeah.
What's the counter argument from supporters? How do they defend against that?
Well, they don't necessarily deny that VCs took profits. I mean, who wouldn't after those kinds of returns? But they argue it was made much worse by the general crypto market crash happening at the same time. Bitcoin dropped massively, everything dropped.
So blame the macro environment partly.
Partly, yeah. And they stress that the initial price action, while damaging to sentiment, doesn't invalidate the underlying technology or the long-term vision. They say focus on the tech, not the initial pump and dump.
But regardless of who's right about the launch, the current reality, based on the metrics we have, shows pretty low adoption compared to those huge ambitions.
That's the core tension right now. You have this arguably very advanced tech, but the usage figures, they're just not there yet. Total value locked, TVL is only around $69 million as of mid-2025. That puts it, 48th among layer ones?
Yeah, not exactly challenging Ethereum or Solana on that front. What about users?
Also quite low, around 4,600 daily active addresses. If your goal is replacing AWS, 4,600 users is, well, a very long way off.
And we have to mention the regulatory cloud, too.
We do. The SEC named ICP as a potential crypto asset security in its lawsuit against Coinbase back in June 2023. That adds another layer of uncertainty.
So you've got strong tech, but this shadow of the launch controversy, low adoption metrics, and regulatory risk. How does a project like this move forward?
Our sources actually suggest there's been a real acceleration recently, mid-2025. Like the builders are just putting their heads down.
They really seem to be. There's definitely a sense of renewed momentum on the development side. Reports of over 2,000 new developers coming into the ecosystem, attracted by grants, hackathons, things like their World Computer Summit in Zurich.
And the focus is shifting towards more advanced features.
Absolutely. The technical roadmap is pushing hard on things relevant now. AI and interoperability seem to be the big theme.
Okay, give us some specifics. What are the key upgrades? Well, they're always working on core scalability, like the Stellarator upgrade late last year, boosted storage and throughput. But the really eye-catching stuff is more recent. Caffeine, for example.
What's Caffeine?
It's their platform, launched in alpha just recently, July 2025, that lets you run AI models directly inside smart contracts on-chain. They're talking about self-writing apps where you use natural language to build things. Very cutting edge.
Wow, AI on-chain. What else?
Privacy and identity are big focuses too. They have things like vet keys for privacy vaults and internet identity, which is their system aiming to replace passwords and seed phrases entirely, giving users proper control.
And interoperability, connecting to other blockchains. That seems crucial if they want to be the internet's backbone.
Totally crucial. Their chain fusion technology is designed for exactly that, allowing ICP canisters to directly call contracts and read state on other blockchains like Bitcoin, Ethereum, Solana, without needing those risky centralized bridges.
Have they actually integrated with any chains yet?
Yes. The Solana integration was completed in June 2025, according to the roadmap, and apparently Dogecoin integration is in progress, aiming for October 2025, so they're actively building those connections.
Okay, so the tech is evolving. Are we seeing real applications being built using this? Things people can actually use?
We are starting to see more examples emerge, yeah. Often directly targeting existing centralized services.
Like what?
On the social media side, there's District aiming to be an open, decentralized LinkedIn, OpenChat as a kind of open source WhatsApp, CanCan as a decentralized TikTok.
Interesting. Any non-social examples?
Yeah, in finance and more enterprise areas, you've got DeFi Starter, which is an IDO launchpad platform built on ICP. And Origin, which is using the IC to track the provenance of high-value assets like luxury watches and fine art, shows the breadth of what the Canister model can potentially handle.
Okay, let's try and wrap this up. We've explored ICP's really different architecture, chain key tech, canisters, the NNS governance, highly performant, designed to run the whole web on-chain, theoretically.
But paired with this incredibly volatile market history, the criticisms around token distribution and, frankly, current low adoption.
The potential, though, if they pull even part of this off.
It's massive. One source estimated that if they capture even 20% of their target market replacing legacy ICP, could easily become a top 10 crypto project by value. But, and it's a huge but, that depends entirely on getting real users, real businesses, real applications running at scale.
They need to convert that technical potential into actual usage to overcome the skepticism and the competition.
Exactly. The market isn't going to forget that price history easily. They need overwhelming proof of utility.
So here's a final thought. We talked about the economics developers pay the compute costs, roughly $5 per GB per year for storage, making it essentially free for the end user. The goal is to replace legacy IT seamlessly.
Right. The user might not even know they're interacting with a blockchain.
So, if the service becomes truly better, faster, maybe cheaper for the developer, and totally invisible and free for the user, does that initial, maybe predatory price collapse ultimately matter in the long run? Could ICP just sort of fade into the background as successful but invisible infrastructure, making the token price almost irrelevant to its function?
That's the billion-dollar question, isn't it? If utility becomes the primary measure and users don't need the token, maybe the market drama becomes just a historical footnote. Success measured by invisibility, not by CoinMarketCap rank. Definitely something for you to think about as you watch this space evolve.